All right, so everybody has their notes out. Math notes specifically. Did we go over this slide yet yesterday? We did, right? All right, but we need to remind ourselves of what's going on here, right? Okay. So we already read this. I'm just going to start pulling out some important information again. Okay? And we face forward and we focus. Okay, there's no reason to turn around unless you get permission. Remember that magic word? Okay. Latanya will walk her bike. So she's walking the bike to the bike shop. We went over this yesterday. Walking her bike to the bike shop at a pace of 3 miles per hour. It says that the bike shop is 1.5 miles from her house. So the distance of this red line is 1.5 miles. What's the distance of the blue line?
1.5 miles.
It's the same, right? She takes the same route home. So okay, terrible handwriting, but you see. 1.5 miles both ways. Okay. She gets the bike fixed. She walks her bike to get it fixed. Stays there for some amount of time, which we don't know yet. Then she rides it home, and of course if she's riding it home now, she's going faster. So it's a different rate, okay? So her rate coming home on the bike is 10 miles per hour. So everything makes sense so far, but then they ask a question that's like, how do we answer this? If the whole errand from here, and then staying to get it fixed, and then biking back here, the whole errand took 1 hour total, right? The whole errand took 1 hour. How much time did Latanya spend at the bike shop? So we're dealing with time, we're dealing with rates, and we're dealing with distance. Does that make sense? We're dealing with time, rates, and distance. Let's see how we can set this up to solve for the missing, time that she spent at the shop. Now, keep in mind that I think we talked yesterday about a rate equaling distance over time, right?
Yeah.
Did we talk about this yesterday? No, that might have been another class. Have you guys heard of this formula?
No.
Rate equals distance over time. What's another word for rate? What do they mean by rate?
Something would be.
What's that? Something one? No, just look at what's a synonym for rate in this scenario?
Speed.
Speed, very good. So rate is the same thing as speed. Give me an example of a speed limit that you've seen. Yes? What is it? 35 miles per hour. 35 miles
You went that fast on a bike?
per, I just asked it for an example of a speed. Because when we see a speed limit sign, it gives us what speed you're allowed to go, right? 35 miles per hour. Per how many hours? 35 miles per
Hour.
1 hour, right? If it says 35 miles per hour, that's 35 miles per 1 hour. Okay, this has nothing to do with the numbers here. It's just understanding that the rate is comparing your distance with your time. Do you guys agree with that? Okay, a rate or a speed is distance over time, 35 miles per hour. When we write that, we would just simply write 35 miles per hour, right? Okay. Tell me if we talked about this yet. Have we talked about that you can switch these and the equation is still true? Have we talked about that yet?
No.
Mind blowing, right? I'll give you an example. Don't worry about this anymore, okay? You can actually switch these, whoops, I meant to write time. Time equals distance over rate.
Oh my gosh.
How am I allowed to do that? I don't know. You want me to show you with the baby equation? Okay, I'm gonna put a little baby equation here, okay?
Isn't it all the same thing? One doesn't have control.
Well, I will tell you this, you can't put them in any order you want. There's a specific thing that you can switch. You can switch your, so do you agree that this is a fraction, which is also a division problem? We would call this number, the number that's being divided, we would call that our dividend, right? We would call this our divisor, and we would call this our quotient. So if this is our dividend, divisor, and quotient, I'm saying you can switch your divisor and your quotient, and your equal sign is still true. I'll show you the baby equation. It's gonna make so much sense.
Oh.
Okay, let's, yeah, you get it. 6, whoops, no, sorry. 3 equals 6 over 2. Dividend divided by the divisor equals the quotient, right? If I switch these, 2 equals 6 divided by 3, is it still true?
Yeah.
Yeah. So I'm allowed to switch those and the equal sign is still true. You can do it with any easy division problem. Let's do 5 equals 10 divided by 2. Is this a true statement?
Yes.
If I switch my divisor and my quotient, and I put the 2 as my quotient, I keep my dividend in place, and then I have my, I put my quotient in my divisor spot, is that still true? 10 divided by 5 equals 2.
Yes.
So we've definitely proven that you are allowed to switcheroo your quotient and your divisor. And we are more familiar with this, which is why I started with this, because we know that a rate or speed is the distance compared with the time. So, because we're more familiar with it because of speed driving a car, right? 40 miles per hour, 50 miles per hour, that kind of thing, or biking, 12 miles per hour. So, the way that they set this up, because we're given the total time, we're actually going to be keeping our units in time. Time walking, plus time at the shop, plus time biking will equal the total time. Now, over here, time equals distance over rate. So the time walking, time equals distance, the 1.5 miles, over her rate, which they gave us. They gave us the distance, they gave us her rate when she was walking. And we just wrote it as a ratio describing the time. Because time equals distance over rate, we've proven that's true, and all we did was write it down. And that's okay, right? The time at the shop, well, that just happens to be what they're asking for. So that's gonna stay our variable. We'll call it T for time. The time biking, just like we were able to represent the time walking with distance over rate, we're gonna represent the time biking with the distance over the rate. 1.5 miles, because we said that the distance is the same, right? Over her rate of biking, 10 miles per hour. And then it also tells us that the total time took 1 hour, so that's our total. Does everybody understand how we set up our equation? Just so it makes sense and we have a missing number, we have values everywhere else. So we only have a missing number. Okay, so now, yeah, yes. So now we're gonna take our numbers here since these equal time, and this is time, and this is time, and miles per hour also equals time, we don't need our units anymore because comparing the distance with the rate is time. So it's time, time, time. So we're just gonna write that as 1.5 over 3 plus t plus 1.5 over 10 equals 1. And that equation is what represents the situation. Take a break, let you guys let that sink in. Tell me if there's something that you are not totally following, and believe me, this is really hard. So there's nothing wrong with you. This is just a really, really hard problem. I know the hardest part is like getting from the words to like figuring out how to write it. And that's why we have examples like this. Yeah.
How are you going to turn it into minutes? So we have to turn it into minutes and add them.
Oh, that's a really, really, really good point. You'll see at the end. Can I give you that answer at the end? Because you're totally right. That's going to be hard to turn it into minutes, but we can actually represent it with blank hours, even if it's less than an hour, like 0.5 hours or 0.2 hours kind of thing. Because you're right, it has to be less than an hour. So how are we going to turn that into minutes? We actually don't need to. So it just says how much time, so you can represent it in like a fraction or decimal of an hour. Okay, so here we go. I'm going to go to the next slide here because that's what's going to help us. Okay, this looks really weird. I'm going to explain everything. So Aubrey, are you okay? Okay. Just overwhelmed or are you okay? Okay. So, and just a reminder, this is not on your quiz tomorrow, but it could show up on a test, so we want to be paying attention and taking notes, right? Everything okay?
Yes.
Okay, good.
Better than ever.
Better than ever, I love it. So this is the same thing we had on the previous slide, okay? This is now up here. This is where it's gonna look weird.
What?
Okay?
What?
Yes. So, how do we get rid of denominators that are different? You know how you're like, well, can I multiply this times 3? And then I multiply this times 10? Well, no, because if we do something to one, we have to do it to everything. But the only way that a number will be able to cancel both of those out is if that number is divisible by both of these. So we're looking for the least common multiple or the least common denominator. They're the same thing. So, least common denominator of 3 and 10, 3 times 10 is 30, right? So all we have to do is multiply each term, every single one, by 30. So when I multiply this times 30, I get 10 times 1.5. I'm not going to do anything else with that right now. When I multiply t times 30, I get, you know what, I'm going to show it down here because I can cancel out the 30 and the 3. 10 times 1.5, and then the 3 cancels out because 30 divided by 3 is 10. Then I have to multiply the 30 times my t, and I have 30t. Then I multiply my next term by 30. 30 divided by 10 is 3. So I have 3 times 1.5. Then I also have to multiply my 1 times 30, and that's 30. And then this is where you can use a calculator if you want to. Makes it nice and easy. We don't have to think too much. I know you can probably do this in your head, right? 10 times 1.5, you just move the decimal over, and that's 15. 30t is just 30t for now. Then we have 3 times 1.5 is 4.5. times 30 is 30. Give me a thumbs up if you get it, thumbs halfway if you kind of get it, thumbs down if you don't get it at all. And don't worry, this is not on camera.
She's not filming?
Oh, it's filming, but it's not filming you, it's just filming me. Okay. Okay.
Wait.
Is there anything you don't understand about the multiplying times 30 part? Yeah, you don't. Do you understand why we multiply times 30?
Is it the?
It's because we wanted to get rid of our denominators and have a nice, easy algebraic equation to work with. It's solving algebraically, it's getting rid of denominators, but we had more than one denominator and they weren't the same.
Are you doing the least or the most common?
Least common denominator, yes. And 30, which we know a lot of the times the least common denominator is just multiplying the two denominators together. Not always. Like the least common denominator of 2 and 8 would be 8. You don't have to multiply to get 16. But you technically could and then just reduce in the end. So we chose 30 because 3 times 10 is 30, and that's what's going to cancel out our denominators. So we have 15 plus 30t plus 4.5 equals 30. This is the easy part. These are the equations that we've been working with all through lesson 1. So we combine what?
15.
We combine the like terms, very good. So 15 and what? 4.5, and we get 19.5. 30t is still just 32t, then what do we do? Yes, thank you. Cancel, and then we get 30t equals 30 minus 19.5. 30t equals 10.5. Then what do we do? Yeah, divide by 30 on both sides. The 30 over 30 cancels out, and we get t equals 10.5 divided by 30.
OMG.
Which gives us a decimal number. So you see how we got like about a third of an hour, right? So 0.3 of an hour is how long she spent at the bike shop.
What?
You would have to convert it, but you don't have to worry about that at this point because they would accept both answers. But I can answer that another time. I just want to get to the. You would just convert it with a proportion from minutes to hours. Okay. How are we doing on time? I think we can do this. Let's do this. Okay. Latanya, here she goes again.
Try.
She leaves her house.
Oh my. Oh my god.
She leaves her house
Again.
at 12:30 p.m. and bikes at 12 miles per hour to Marta's house.
Who's Marty?
Her friend, I guess. She stays at, quiet please, she stays at Marta's house for 90 minutes. Then Marta and Latanya, both girls, walk back to Latanya's house along the same route
Maybe she loves the same route. That's
at 25 miles per hour. They arrive at Latanya's house at 3:30 p.m. How far is Marta's house from Latanya's house?
12 miles.
Okay. Okay, let's see, okay? So Latanya leaves her house at 12:30 and bikes at 12 miles per hour to Martha's house. So Latanya bikes. Okay, that's taking a certain amount of time. Then it says she spends 90 minutes at the house. Then they walk back. So Latanya bikes and then both girls walk back. Both girls walk back. And the whole thing takes how long?
3 hours.
3 hours, very good, 12:30 to
Good job, good job.
Now, I will say, we're dealing with time in minutes here and hours here. Why don't we convert this 90 minutes to, go ahead.
An hour and a half.
Good, 1.5 hours. So we have 1.5 hours and 3 hours. Okay, so we need the time. The time is the distance over the rate.
Again?
Yes, again, but we don't know the distance. So that's our variable.
Is that the rate,
We're using time because they're giving us the times.
Why is it 1.1?
So we're using time for everything. We're using the time that it takes Latanya, the time it takes Latanya to bike, and the time that the both girls walk back, the time that she spends there, and the total time. Just like we were doing before, time plus time plus time plus time, just total time. Okay, so we don't know the distance. Do we know the rate? What's the rate? 12 miles per hour. Okay. So now we have the time represented in distance over 12 miles per hour. Then we have plus 1.5 hours, plus now we need the time represented in distance over rate. Do we know the distance of walking back? No, because again, that's our variable. How far is Martha's house from Latanya's house? We don't know. The distance is unknown. We just know the rate. The distance is unknown. We just know the rate. What is it? 2.5. And then all of that together, this time plus this time plus this time is 3 hours. Again, this doesn't look like a time, but we did establish that if rate is distance over time, then we can switch those and time is distance over rate, okay? Now, what did we do next? Do you remember? We have those pesky denominators. I'm gonna erase this label here. We have these pesky denominators. What do? The least common denominator. We're multiplying every term times the least common denominator. Okay? Another thing you can do if you want to keep this a little bit simpler, you can just subtract 1.5 now. We have 3 hours minus 1.5. You can do it either way. You can do that at the end, but then we don't have to multiply over there. So we have d over 12 plus d over 2.5 equals 1.5, right?
What?
When we take 3 minus 1.5, we get 1.5. So let's go ahead and what is the least common denominator of 12 and 2.5? What should we do with those numbers to find the least common denominator?
Not fair. Division.
What did we do with the other ones?
Multiply.
Multiply, right? So if I multiply 12 times 2.5, I get 12 times 2.5. I get 30. We can add uncommon denominators. Yeah. All right, so if I get a least common denominator of 30, I have to multiply everything times 30. So times 30 here, times 30 here, and times 30 here. Since I actually knew the time that she spent there, I was able to just subtract that and then kind of simplify it a little bit, okay? So, I'm just gonna erase this just so I can have some room up here, okay? So I'm gonna rewrite this up here. I've got my 30 times d over 12 plus 30 times d over 2.5 equals 1.5 times 30. I'm just rewriting it so that I have more space. Okay. Now, we have 30D divided by 12. I'm going to tell you a little trick. Since we want to get rid of these, we're not just finding like, oh, I can just reduce this, because then we're still going to have a denominator. We actually have to divide to get a numerator with no denominator. So what's 30 divided by 12? 30 divided by 12 is 2.5. Remember, it was multiplied times 2.5 to get 30. So if you divide it by 12, it's 2.5D. So 30 divided by 12, we did that and we got 2.5D. Denominator is gone. What's 30 divided by 2.5 then? What'd you say? 12, very good. So we have 12D equals 1.5 times 30. It's what? 45. Yeah, 45. And feel free to use a calculator if you want to give your brain a break. I know this. The most important part is writing the equation. And guys, again, it's super hard. It's not you if it feels hard. You know that, right? It's not you. This is super, super hard. Okay? I want to teach it to you because it might be the hardest question you'll ever see on your end of course exam this year.
30 divided by 2.5 is 12.
Yes, 30 divided. Remember, we multiplied them together to get 30. So if you divide them by each one, you'll get the other one. Yeah. Okay, so now what can we do? Yeah, we can combine them, right? So we have 2.5 plus 12 is
14.5.
14.5 D equals 45. Last step. Divide by 5. Divide by 14.5. Go ahead and use your calculator for that one. 45. 45 divided by 14.5 equals a long decimal number. We're going to round to the nearest 10. That would be about, so D is about 3.1. The distance is about 3.1 miles, right?
3.103448.
Do you agree that this problem is ridiculously hard?
Yes.
Yes, I agree with that. Are you guys proud of yourselves that you were paying attention the whole time to it?
Yep.
Is it okay that you don't fully understand it? Is it okay that if I gave you another problem like this, you might not know where to start? Yes, because it's the first time we've ever worked on it. I don't expect you guys to know this right away. We're just working on it together. So give yourselves grace and give yourself a pat on the back. Nope, it's not on your quiz. It could show up on your test. So give yourself a big pat on the back because you guys were really focused and this was really, really, really tricky.
So on our test tomorrow, we're not going to have a question like this?
Not on the quiz. Go ahead and take out, you guys have about 5 minutes if you want to take out your quiz and start working on it. Take a few minutes. I didn't ask for talking or noise. I said you can take some time to work on that homework, which is your quiz